Siyanamukela ohlelweni lwe-Ithala Edu platform enilethulelwa ngezilokotho ezinhle Ithala kanye ne-GoDigitalSA Foundation. Thamelani izifundo ze-mathematics, i-accounting, isiZulu ulimi lwasekhaya, isiNgisi, i-FAL, i-physical science, i-geography, ezobuchwepheshe, i-computer applications technology kanye namaklasi e-learner wellness okungukuzilolonga ngokomqondo kanye nomzimba. Lezi zifundo zethulwa nsuku zonke kusukela ngoMsombuluko kuya ngoLwesihlanu kuqala ngehora lesi-4 kuya kwelesihlanu u-4 kuya ku-5 ntambama nangoMgqibelo kusukela ligamanxe ihora lesi-8 8:30 kuze kugamanxe ihora lokuqala emini 1:30. Zithameleni futhi lezi zifundo emsakazweni Ukhozi FM njalo ngoLwesine kusukela ngo-9 kuya ku-10 ebusuku. Ningangena ekhasini lethu lika-Facebook elithi GoDigitalSA_movement noma kwi-YouTube uthi GoDigitalSA Foundation. Siyethemba nizolijabulela lolu hlelo oluhlose ukunifundisa futhi lulekelele kulokho enikufunda ezikoleni zenu. Luthokozeleni-ke lolu hlelo nimeme nabo bonke abanye abafundi bebanga le-12 grade 12 ukuze nabo bazuze kulo futhi nonke nicijeleke ukuphumelela kwizivivinyo zenu zokuphela konyaka.
Sanibonani bafundi. Today's lesson a continuation from where we left last time. Work energy and power. Last week sakhuluma nge-energy, where we could look at what is the potential energy, gravitational potential energy, what is the kinetic energy, and the mechanical energy. Then sabuga conservation of mechanical energy. Then emva kwalokho sakhuluma conservation. We did one example of a conservation of mechanical energy. Emva kwalokho sakhuluma work done. Someone will work done calculator kanjani as a product of the force and delta x, that is the distance or the displacement of the object. Sakhuluma futhi ngokuthi sinama 3 types of work done. Singaba ne-positive work done, kube ne-negative work done, kube ne-zero work done. Second, positive work done if the force is exerted in the same direction as the displacement of the object. Lapho sikhuluma nge-positive work done. If the force is exerted in the opposite direction to the displacement of the object, then sikhuluma nge-negative work done. Kuzoba khona ne-zero work done when the object or the force is exerted perpendicular to the displacement. Now, emva kwalokho sikhulume ngama-forces ngoba i-work done ngokwe-definition masibhala sithi work done is equal to the force times delta x times cos theta. This force here is the one that is doing work. So it's the work done by this force. Then sabu uti on an object siyakwazi ukuthola ama-forces a-acta kwi object, and each force iyakwazi ukuthola i-work done of that particular force. So kuwena-ke usuyabona ukuthi le force ihambisana ne-motion noma iphambana ne-motion noma it's perpendicular to the motion before you apply anything. So uzokwazi ukuthola ukuthi the work done, is it positive, is it negative noma ku-zero. Then emva kwalokho sakhuluma ngama-forces. Sine gravitational force, normal force, sine frictional force, sine tension force, as well as the applied force. Sakhuluma nge-net work done. Uthi net work done siyakwazi ukuhlanganisa ama-work done by all the different forces. Masuno net work done sikhuluma work done by force number 1. Kuyadependa whether ukhuluma nge-gravitational force noma friction noma normal and so on, plus work done by the other force, plus work done by the other force, whatever the number of forces you are having. So each force will have what? A work done. le work done ingenzeka ibe positive, ibe negative, noma ibe zero. That depend on the case, depend on the force that we are talking about. Beside local, sibona ukuthi net work done can also be calculated mawusebenzisa net force. Ngoba uyazi ukuthi mase net force kusho ukuthi sesihlanganise ama forces wonke. Then we have the the F net, that is the net force. The net force sihlanganise ama forces wonke labo F1, F2, F3. Then sort it times delta X times cos theta. The emphasis was on lo theta. The theta was the angle made by the force with what? With the motion. Now, last time the makune force actor on the object. The angle theta ingaba u0, makuthi if force is makune positive work done. If the work done is positive, kusho layer force layer angle color from 0 ingaba u0 until not 90 ngoba ngaba mhlambe u89 so lapho. Anything around there, force angle ekhona ezokukhiphela abantu positive work done. Then masine negative work done, makune negative work done, angle yakhona lo theta wakhona, the theta will be what? 180 degrees, like a frictional force. So for frictional force ngoba ngisho i-definition isho ukuthi it's a force that opposes the motion. Kusho ukuthi yona ihlezi iphambana ne-motion object. So the angle made by the force, the frictional force, is always what? 180 degrees. And that will give you what? A negative work done. Then sakhuluma nge-zero work done. So no zero work done if theta 90 degrees, noma theta ubani 270 degrees. There we have a zero work done. So beside that, nisakhuluma nge work energy theorem. So menge work energy theorem leothi that the net work done on an object is equal to the change in the kinetic energy of that object. That is a theorem. Nikezwa kanjalo kwi formula sheet, and the way it is, ma show this thing in word, it simply gives you what? That theorem, then work energy theorem. So mawubuka ukuthi kuno net work done, ongakwazi uku-calculate uhlanganisa ama work done for all the forces, noma ucalculate net work done ukwazi ukuhlanganisa wonke ama forces bese uthi times delta x times cos theta, noma ube net work done uthi time that is equal to the change in the kinetic energy. So if we unpack this change in kinetic energy, kuyasho ukuthi sine final kinetic energy minus or initial kinetic energy. So the formula kinetic energy is half mvf squared ngoba sikhuluma nge final kinetic energy minus half mvi squared, initial velocity object. So you still uyabona ukuthi lana sikhuluma ngama forces, kanti lana sikhuluma ngani? Nge velocity. So you can relate those two, velocity and to those forces. So uyakwazi ukusuka lana ku net work done using a theorem, work energy theorem, ikuyise lana kuma forces, where you can now be able ukuthola a work done by individual force. Last time sasithola example yani work done by the frictional force ngoba umbuzo othi calculate the coefficient of friction. Masazi ukuthi work done by frictional force, it's what? A frictional force times delta x times what? Cos theta. Lo theta siyamazi uhlezi 180 makhulunywa ngani? The frictional force. So if you have this one, let's say we are told work done by the frictional force. So this one is known. If distance then you can get what? A frictional force. Well, frictional force, we have the frictional force is coefficient of friction times the normal. So normally we calculate, then the coefficient of friction can be calculated easily. Lokhu kusuka kephi kuma velocity. Right, ngoba uthola velocity initial and final velocity Mohlanganisa ama velocity according to theorem nigabani W net. That is the net work done. With that net work done, we sangala with the net work done. That is the sum of all the work done on that particular object, right? And each work done is work done by a particular force. So we can now be able to integrate a mechanical energy to the net work done. Now as buke isibalo lana ezosiza ukuthi sibone ukuthi singasuka kanjani kwi conservation of mechanical energy to work done. Now let's say we have an example here. Uti suga ku point P, kuno point Q, kuno point R. Then sabe kune bogisi, 50 kg, just an example. 50 kg. Between P and Q, leo portion leo height at 3 meters. PQ is frictionless, aik friction. Remember, for conservation of mechanical energy, besikhuluma ngokuthi in an isolated system. Frictionless, already we are having a chance of being in an isolated system. It's a frictionless. Bese kuba space between Q and R. Between Q and R, a distance of 5 meters. Yabona usinikezwe 5 meters, so you understand the issue yani your delta x lab. Then kuzothiwa ke this object slide from point P to point R. Kodwa distance QR, distance QR is a rough surface. Mokuthiwa rough surface means what? Called friction. So when the object is sliding from that point, from Q to R, I see to the slambes in a frictional force ka 35 newtons. There is a constant frictional force ka 35 newtons. Now we need to get what is speed, suppose below 50 kg when it reaches what? Point R. Calculate the speed of the box, the speed at point R. The speed at point R. Right. As we analyze the equation from point P, the object is stationary. The object is stationary, so siyazi kinetic energy is 0 at that point. At point Q, that is below there. So when this object starts sliding on a frictionless surface, it is decreasing in terms of what? In terms of height. So it means the potential energy here decreases as the object moves from P to Q. But it started from the initial position. This means the kinetic energy is 0. But as it's going down, its speed is here increases. So we need what? We need to know what's gonna be the speed at point Q. Because the question is, we want to get what? The speed at point R. Why singakwazi ukusebenzisa part P to R straight ingoba between Q and R khona friction ekhona. So we cannot use the conservation of mechanical energy. But between P and Q, siyakwazi ngoba it is a frictionless surface. Right, so the first thing, speed normal, speed say also objects, 50 kg at point Q. So what do we know from there if we apply a conservation of mechanical energy? Look, the mechanical energy at P is equal to the mechanical energy at Q, because that surface there is frictionless. So mechanical energy is calculator is the sum of the gravitational potential energy, that is mgh, plus kinetic energy, half mv squared, is equal to mgh, at this time calculator at point Q, plus half mv squared. then senza substitution. At point P, the mass of the object is 50, G is 9,8, the height is 3. I want to start with 3 lona kushoguti. Point Q is our reference point. So it's calculator a mechanical energy relative to what? To point Q, not to point R ngoba asazi le distance le asiyas. Then it's 9,8 times H, the H is 3, plus at point P, this object is at rest, kushoguti 0 at that point because the velocity is 0. Then sizelana with Q. Q is our reference point, kushoguti height yakona ubani 0. Then plus half times 50 times what? V squared. V squared, that is the speed that we want. Velocity, no speed at point Q. So we have V squared. In that case, sesingakwazi calculate abani V at point Q. See to VQ. Right. Now once that's a calculator, now it is square there, so it will be a square root of on what is on the left side, 50. 50 times 9,8 times 3. Right, this divide, but let us know half of 50, half of 32 banu 25. So this times 25, then sniga banu 7,67. 7,67 meters per second. That is the speed at point Q. Now, seen a speed at point Q. So what we need now to get, our question was to get the speed at point R. The speed at point R. Masuga from Q to R. Let's see what will guide us. Already masimo nanje distance nigezo distance is no delta x. Masino delta x si kulumangani nge work done. But also ngoba sine distance and kulumanga nge speed. How can we reach this point? Now we have a speed at that point. Now we need the speed at point R. As far as the conservation of mechanical energy ngoba, the path Q to R has what? Has friction. Kadilio principle issue goti fancy we isolated system. So now into says yogoti masuga from Q to R. Speed say objects is ocean, but there is also what? A friction. So the first thing jalo maskuluma nge work done if I see in a free body diagram when the object is moving from Q to R. Let's draw it. From Q to R, when this object is there, Conan gravitational force that will be there. Now the object is going downward. There is no force but there is a friction. A friction always opposing the motion, so it will be upward like that. Mesekuba Conan normal. Normal force ikonangoba it is on an object. Now this object is going down the slope. Koto aiki force don't accept what a gravitational force. Now last time that if we have an incline, as we break a gravitational force into ama component so that soboni component is nani the frictional force. Right, in that case, singaba nani 40 normal. The normal is there. Then we have a frictional force. FG parallel. FG perpendicular. Right. Now, looking at that one, we need also the angle. Kalana, that will be a 30 degrees. We have 30 degrees. Now, masibu and emotion yetu, only these two forces are what? Are parallel to the motion. What are frictional force or actor opposite or FG parallel hamsana the motion object. In normal and FG perpendicular, they are perpendicular to it. Lava snikabani in work done, that is 0. Right. So from there, siawazi wenzani calculator in net work done. Goba siawazi ama forces. The net work done on this object will be what? A work done by FG parallel plus a work done by frictional force plus work done by the normal plus work done by FG perpendicular. Now siyakwazi u replace ake lama values. Net work done by FG parallel. FG parallel siyazi to calculate as FG times sine theta. So this will be FG, and the FG is M times G. So we'll have FG times delta X times what? Cos theta plus frictional force times delta X times cos theta. Lababa 2 W net and W normal and WFG parallel, they are what? They're all 0 because they are perpendicular to the motion. So singayenza in a substitution. W net FG is M imese 250 times 9,8 times its distance is negation, it's 5 times cos kabani as 0 ngoba FG parallel is in the same direction as the motion, cos 0 plus frictional force. Sitay value of frictional force to 35 newtons. So 35 newtons times delta X is 5 times cos ka 180. Then plus what? Plus U0. So we are siyawazi ufaka calculator yonke into sibona ukuthi sothola bani as the net work done. So the first part is 50 times 9,8 times the cos of what? Of 0. Siyazi the cos of 0 is 1 plus the second part 35 times 5 times cos of what? Of 180. So we have 50 times 9,8 times cos of 0, so 1, then so t plus 35 times 5 times -1 times -1. So this one gave us what? 315. So the net work done or 315 joules. 315 joules. That is the network done. Why is funalo network done? Ingoba the question want to get what is speed at point R. We want to get the speed at this point R here. So we have the network done. If we have the network done, so this simply means that siyakwazi kusuka ku network done isise kuma speed, because in that case sesosebenzisa bani work energy theorem. W net is equal to the change in the kinetic energy. W net sesiyamazi ngoba simtolile from other forces. So that's how those network done are related to each other. Now the other thing, ngoba W net siyamazi 315 after our calculations. So we can now do what? A substitution. So W net is equal to kinetic energy at point R. Remember that is the final point at point R minus kinetic energy at point Q. So if we break it down, so W net is equal to half mv squared, mvr squared, this is what you're looking for, minus half mvq squared. Remember v at point Q says you calculate using what? Conservation of mechanical energy. So if we do the substitution, then W net yamazi 315 is equal to half times 50 times VR squared. That one we know. Then minus half times 50 times V at point Q. We calculated it earlier on and we got what? 7,767 times 7,767 comma 67. This had to be what? Squared. So we can get what is our speed at point R. That will be what is a square root. So we have 315 plus, I transpose this part here, is 25 times 7,67 squared. That will be the numerator. Divide by 25. Divide by 25. Right? It gives us what? 8. So speed at point R is what? 8,45 meters per second. So that is how you calculate. Now we are going to go take SILSA from one principle to another. The first one, this one, it is one of the energy principles. Normally, let's say for PQ, the conservation of mechanical energy. It's also what? It's also a energy principle. So umbuzo ngati kuti sebenzisa energy principles to calculate anything that will include energy. It is an energy principle. Yeah, singasebenzisa the conservation of mechanical energy. Normally we sebenzisa then the mechanical energy here, the work energy theorem is still what? It's still energy principle. Now, any to follow kapelo ukuthi njalo mesubuzwa nje the O level 1 question lapho to state something, to state energy work energy theorem. Just know ukuthi the structure of the paper it you draw, you state, and then you apply. Draw, state, apply. Right? All the questions are like that. DSA. Uti draw. That's why uti draw a free body diagram. Something like that. State. When you state, lapu define, you state what the theorem or a law, say we apply. Right? You apply. So when they say state work energy theorem, just know what the following calculation is also the same law that you stated. Mark to a state work energy theorem. When we are looking the net work energy theorem is the net work done is equal to the change in the kinetic energy. Just be sure after stating that the following question, because it's the application of this law, you'll have to use this formula here. You should know that. They can't ask you what the state work energy theorem. Calculation is a calculation on what? On conservation of mechanical energy. It's not like that. So because this ni understanding like ama forces. Can you state if you are able to state we apply. So it's always like that. You state the law or you define something, a concept, then you have to apply the concept. So you're about to the formula, then after stating, you have to apply it is 1 mark. Because here again, 2 marks from the formula. That you are going to know 2 marks in 2 marks for stating the law. The same laws we state work energy theorem in word, in symbols. Right? Then we apply it, calculate any calculation that will follow that statement will be related to this one. So by writing down the formula again that you are given, that is 1 mark for doing that and making sure that une substitution it is. Right? That's how easy things will be. Right? We're talking about the application of this. So every time, just know what integrate 2 different topics. For example, momentum can be integrated to conservation of mechanical energy. At this time, siyakhuluma futhi conservation of mechanical energy, work energy theorem. So you have all those integrations. So you have to be able what do you need from the statement and what you need to calculate. Then it's a guidance, right? So that Now the next thing esokhuluma ngayo it's ama forces. The forces that we talk about here will be ama conservative forces and non-conservative forces. Right? Conservative forces and non-conservative forces. Non-conservative forces. Right, under my conservative forces, these are the forces for which the work done is independent of the path taken. The work done is independent. The work done by this conservative force is independent of the path taken. Right, like for example, examples. Conservative forces, we have FG, we can have an elastic force, we can also have what electric forces or electrostatic forces. You have electric forces. These are examples of what? Of non-conservative forces. Then kubekona a non-conservative force. The non-conservative force is the force for which the work done in moving an object is dependent on the path taken. Right? Now, if I have to explain about the conservative force, for example, FG, if an object is moving upward, if the object is moving upward, FG is still downward. If the object is falling down, it means moving downward, FG is still what? Still downward. That is a conservative force. For a non-conservative force, because it depends on the path taken, example of a frictional force. But on the frictional force, if the object is going upward, the frictional force is downward. If the object goes downward, the frictional force is upward. So it always depends on the path taken. So understand that in that way. So non-conservative force, the main one we talk, the common one is the frictional force. You can also have the air friction, you can have tension, you can have force applied. All these are what? Are non-conservative forces. Right? A push or a pull, an applied force is also what? A non-conservative force. Now, when we include now a non-conservative force kuma calculations, because sometimes ungabona ukuthi ufuna ukusebenzisa W net work done as to apply it work energy theorem. Ubona ukuthi ushotelwa ngama informations athize, but ubona ukuthi now I do have a frictional force, and we understand that the frictional force is a non-conservative force. So uyakwazi uku-apply for conservation theorem, work energy theorem, but this time work energy theorem ihambisana non-conservative force. So that theorem is like the work done by a non-conservative force. The work done by a non-conservative force, it will be what? The change in the kinetic energy plus the change in the potential energy. This is the work done by a non-conservative force. When uzobona ke example, a non-conservative force, which non-conservative force are you using? Right? Most of the times we talk to a friction. So if we can break down this one, work done by non-conservative force. So a change in kinetic energy. So it's about half mvf squared minus half mvi squared. That is the change in the kinetic energy plus change in the potential energy. The potential energy is mgh final minus mgh initial. So it's always about that. So as we apply the work done by a non-conservative force, and you can still use it. So potential energy, the height is involved. The height is involved. So you can have a question where you know here I need to use what? The conservation of the non-conservative force, the work done by a non-conservative force. Right, so that is what you need to understand. This one is also one of the energy principles. Energy principles. Ngoba kule sibalo kade sinaso, right? We could see that by having a situation like this, sometimes ushothula ngama forces, you don't know what is the force applied, noma awunikezwa ngisho i-mass ye-object, but you find that the only force you can be able to calculate is what? Is the frictional force. So in that case, you'll use now what? The work done by the non-conservative force, right? So that is what you need to understand from there. Right, before senze esinye isibalo, let's look at the other concept ngoba itopic yethu ikhuluma nge-work energy and power. Sesikhulume nge-energy, sikhuluma nge-work done, then sokhuluma ngani nge-power at this point in time. Right, as it said work energy and power, I said that when you are looking at your question, so that you are aware of what you have to expect from a exam, the examiner will always give you what? A question on what? On work done. The question on work done will be there. Then on these two, it's either bazokhuluma nge-power noma bakhulume ngani nge-energy. So most of the time it's like that. But question on work done, it will always be there. Na kungenzeka bangakhulumi nge-energy kodwa khulunywe ngani? Khulunywe nge-power. But at the end, lama topics ayangenelana. You cannot talk about energy and without talking about power as well, because they have what? There is that relationship that exists, right? So maskuluma nge-power. City power, by definition, the power is the rate at which work is done. Power is the rate at which work is done. Mankulumango rate it over delta T. Rate at which work is done. So I have to put what? A W on top. Rate at which work is done. Right? So that is power. Rate at which work is done. And remember, work done is the product of the force N and delta X. So that is the formula for power. Right, if we try to break down this formula, it work done as you would see calculator as a product, a force, and what? And delta X. They just make it simple. So as you would see work done is force times delta X. Single no cos theta, whatever, it's fine. But the product, force and delta X. So in that case, if theta value W C is la phezulu, so we say P is equal to force times delta X, that represent the work done, over bani over delta T. Then sibuyela ka grade 10 sasikhuluma ngama equations of motion. Masikhuluma nge-motion, there is this part here, delta X over delta T. Rate of what? Change, do you have what? A displacement on top, and that one is what we call a velocity. So we'll have that the power is now equal to F times V. Go by the formula ikunika bani a velocity. This power here we call it what? The average power. Right? So if we have to calculate the average power, so skuluma ngoti average power is the force times what? The average velocity. Right, so you have that. So it's not a new formula as such. Like power, the average power is equal to force times the velocity. No mangala skulumang power is the rate at which work is done. So that is the formula. You can see that this one, it was just derived from the formula Ela Pezu. Right, so that is for power. Right, the power is expressed in watts. The power is expressed in watt, and you have the force in newtons, and the average velocity will be in what? In meters per second. That's a single start isibalo, and then we say that our topic will be covered from there. Right, now you have an object. There is an object, a city object, 5 kg. there is point A, point B, point C, and point D. Right, then so portion AB is frictionless. There is no friction. Right, maybe this is at the height 2 meters. That is the starting point. The 5 kg is at rest. Right, then it will reach point B, then the object will slide until point D, but the distance between B to C obani hlambe 10 meters. 10 meters between distance between B and C. There is a friction. There is a frictional force that is there. This object will travel and comes to rest at point D. It comes to rest at point D. Right? So that's what you have. Now, by that time, umbuzo ungathi ukuthi let's say you have an angle noma bakunika i-height ingakala from point D, noma bakutshela to calculate that height that is there, noma bakunika futhi nale distance uzosuka ngayo from C to D, for example. Right? So what you need to understand, between B and C there is what? There is friction. So it is what? A rough surface between B and C. Right? Now, because the object is sliding, when it's between A and B, you can draw what? A free body diagram. But because it is frictionless, it means singasebenzisa i-conservation of mechanical energy ukuze sithole i-speed say object at point B. Then from there, due to inertia, the object will slide from B to C. It will slide from B to C. Now, if there is a presence of friction, lokhu kuzosho ukuthi the object at point C, when it reaches point C, the speed of the object will do what? Will decrease. Ngenxa yani yale frictional force. Otherwise, if it's also frictionless, kusho ukuthi speed at point B izolingana ne speed at point C. But due to friction, then the speed of point D will do at point C will be less than the speed at point B. Now, every time on a speed out 2 at one point and the other, it means what? You can have what? A change in speed. If there is a change in speed, you can also have the change in kinetic energy. Then a change in kinetic energy also gives you what? The net work done. So you understand that how things are related to each other. Right? From point B to point C, you still can find what? Something. Now they can ask you any velocity at point C. What is the velocity at point C? If the frictional force urban or 3 newtons, no matter what here, 3 newtons. We have a frictional force of 3 newtons. What's gonna be the velocity at point C? Then the same object will reach what? The maximum height here. When they say it comes to rest again, it will stop at point D. Now, from all those things, you find that if from C to D is also a rough surface, this simply means that you have what? You have a friction between C and D. But the frictional force between C and D, we are not saying that is the same as the frictional force between B and C. So what we can do first, as calculated, what's gonna be the speed at point B. From there, we are using what? A conservation of mechanical energy. So as we go to at point A, the mechanical energy at A is equal to the mechanical energy at point B. That one we know, right? So we can find what is the speed at point B. So that masuga from point B to C, we can know what is the speed at point C, right? So at point B, we have mgh plus half mv squared is equal to mgh plus half mv squared. So here we have the height is 2 meters, we have the mass is 5 times 9,8 times 2 plus kutiwa the object is at rest, so velocity is 0 means the kinetic energy is also 0, is equal to mgh. B is at the lowest position, so that is what? 0. But there is no potential energy, or all the potential energy have been converted into kinetic energy, plus half times 5 times what? Times v squared. V squared is simfuna because that is the speed at point B. So again, when you do our calculation, we'll get that this v here, right? Don't forget the square root sign. It's 5 times 9,8 times 2. This divided by 2.5. Half of 5 is there. So number 6,26 meters per second. That is the initial velocity at point B. So we can call it what? VB. Right, now let's look at the other thing. Between B and C. Between B and C, there is what? A frictional force. Now, if there is a frictional force, what can we use? Because our point can now be to calculate what gonna be the speed at point C. So what can we do here? At point B, we know the speed is 6,26. Then at point C, we want to get that the distance is 10 meters, a frictional force or 3 newtons. That's all. The first thing has to have a free body diagram. So a free body diagram when the object is moving from B to C. What we understand, gravitational force, there is the normal force, there is also what? A frictional force. There is no force that is pulling it this way over. Here it's down moving due to gravity, right? So you have those two. Now, if you have to calculate the net force on this object, only the frictional force will be equal to the net force. So we can now calculate the work done by each individual force. Again, Singatola work done by what? By frictional force. See, frictional force here was that will be frictional force times delta x times what? Cos theta. And from our example, excuse, the frictional force of 3, delta x is 10, then cos carbon 180 degrees. So we'll have what? Negative 30 joules. This frictional force has given us a work done that is negative. The other work done with the normal is always what? 0. We have 0 joules. Remember that on the normal force, even from the definition, it is what? It is acting perpendicular to the surface. Then the work done by a gravitational force, now it's what? It's 0. Frictional gravitational force now acts perpendicular to the object. So in another word, the net work done, that will be the work done by friction plus work done by gravity plus work done by normal. So this will be what? W net will be equal to negative 30 plus 0 plus 0. So in net work done here too is equal to what? To negative 30 joules. That is our network done. Then go back in a network done and sifuna is speed at point C. Siazuguti, the network done is related to velocity, speed of the object. So we can be able to do what? To do the calculation. Which principle do we put in? Or which theorem we have here? Is the theorem that will relate the network done to what? To the kinetic energy. So we say that The net work done on an object is equal to the change in the kinetic energy. So you have final kinetic energy minus initial kinetic energy, a work energy theorem. So W net, we know it's negative 30 is equal to final kinetic energy. That will be half, the mass is 5 times what? V squared. That's what we want to calculate. Minus initial kinetic energy. It's half times what? Times 5 times initial velocity. The initial velocity, that will be the velocity at point B. Log over 6,26 all squared. So siyakwazi to calculate abani V. So what gonna be our V in that case, right? So we have to do that calculation. So we have negative 30. Now, if you look at the information that we have here, if we are getting a velocity that is negative, this simply means that the frictional force here was greater, and simply means that the object couldn't reach what? Point C. Right? Let's see what we have here. So we have negative 30. We have negative 30 plus, now we are talking about these two here. Now this will be 2,5 times 6,26 squared. Then we have over 2,5. Right? Sniga 5, we have a speed of 5,21 meters per second. So the speed of the object when it reaches point C will be what? 5,21. And yakumbulu ukuthi at point B with what? With the velocity of 6,26. So as it moves from B to C, its speed here decreases due to the presence of what? Of the frictional force. Then you have the speed at the bottom here. Right? The speed at the bottom at point C is what? Is 5,21. So what else can be a question here is maybe to find what is the height, or what is the distance between C and D. What is the distance between C and D, so that you know at that particular point the height that we have here. Let's say we have 1,5 meters. Right? What's gonna be this distance? That will lead to a situation where the object, this object will come to stop at point D. Right? From C to D, that's what we want. Now we are separating, that is like another motion from C to D. From C to D, we have the objects in a speed esobani 5,21. From here, this is point C, this is point D. At point D, the speed is 0 because they say the object comes to rest at point D. But at point C, the speed is 5,21 meters per second. The height here, we are told, is 1,5 meters. Right? So what we need to get here is this distance. Right? Now, if you look at that point, you can approach this in two ways. As a box, by the time isuka from C to D, what are the forces that are exerted on that particular object when the object is moving from C to D? What we know is that there is a gravitational force, or Fg, konane normal, then konane frictional force. But we know that the object is going upward. It's going upward, right, from C from C to D. Right, that is one of the possibilities. Now, we break it down FG as in terms of ama forces. So banana no FF frictional force, then so no FG parallel, sibenale normal, and then there is also what FG perpendicular. Now the problem with FG parallel, siyabona ukuthi uma calculate FG parallel ku include in angle ngoba sidinga FG times what sin theta. Manje lo theta asina as the angle. Now we have to look at what is the other possibility. Into siyaziyo ukuthi speed at C siyasazi, speed at D is 0, the height at C is 0, the height at D is 1,5. And masibuga under this object, by the time inyuga from C to D, there is a frictional force. So the frictional force, it is what? One of the non-conservative forces. So siyakwazi ukusebenzisa leo theorem ezosebenzisa bani non-conservative forces. So we know ukuthi the work done by the non-conservative force, right, that will be the change in the potential energy plus the change in the kinetic energy. So from there, siyawazi calculator, break it down. So this will be mgh minus mgh final, then so t plus half mv squared minus half mv squared at point C. Right, so when we do our substitutions, the mass is 5, the height is 1,5 minus 0. Remember at point C is at point 0 plus, then on the other side, speed say object when it reaches D is 0, so it's gonna be 0 minus what? Half mv squared, that is also what? 5. The mass of the object is 5 times the speed when the object is at C. So get a calculator and install bani 5,21 all squared. So my sense my calculations, so tologuti the work done by the non-conservative force, that will be 5 times 9,8 times 1,5, then this one plus that will be minus due to this one, so 2,5 times 5,21 all squared kusiniga ban 5,64 joules. That is the work done by the non-conservative force that we have. Right, from there you can now work out anything else that you want from that particular value that you have as the work done by the non-conservative force. So in that case, if you have this situation, you have the non-conservative force and you understand that the conservative force that you have is the frictional force. So if we have that work done by the non-conservative force, you got the value and you know that the non-conservative force you have is what? Is the frictional force. And you are to calculator, that is frictional force times delta x times cos theta. Now the value so then frictional force because we're given from B to C and C to D, then a distance delta x can be easily calculated. So you want to move from one concept to another and kuzokusiza lokho in terms of getting all ama answers. Right, so that is what we need to discuss. We needed to discuss namhlanje. Then next week sesokhuluma ngenye topic that will be electrostatics. A revision grade from grade 11 electrostatics. So it cut on Tuesday and so it cut on the same day. Right, thank you.
Siyathemba nifunde kahle nasithokozela isifundo sethu sanamhlanje. Enisethulelwe ngezilokotho ezinhle Ithala libambisene neGoDigitalSA Foundation. Thamelani ke futhi esilandelayo ngesikhathi sifanayo. Ningakhohlwa ukumema nabanye abafundi bebanga le-12 ukuze nabo basizakale kulolu hlelo. Uma ninemibuzo noma nifisa ukuxhumana nathi, ningasithinta ngokufaka imibuzo yenu kwinombolo yethu ye-WhatsApp ethi 068 151 1072. Mfundi, ungakhohlwa ukubhala isifundo obuza ngaso ngaphambi kokubhala umbuzo wakho. Angiyiphinde inamba yethu 068 151 1072. Siyabonga.